250.97 prohibits the termination of metal-clad cable with a cut-short grounding conductor into a box with concentric knockouts. This prohibition exists because a concentric knockout creates a gap between the cable connector and the box wall. This gap can compromise the grounding path. Metal-clad cable with a cut-short grounding conductor can only be used in circuits up to 250 volts. Higher voltages may cause arcing across the gap between the cable connector and the box wall. Terminating metal-clad cable with a cut-short grounding conductor into a box with eccentric knockouts can create bonding and grounding issues. This is because the grounding conductor is not properly bonded to the box. The manufacturer's instructions for the cable must be followed to ensure proper bonding and grounding. Snap-in style connectors are not approved for use with metal-clad cable with a cut-short grounding conductor. This disapproval is because the snap-in action can damage the grounding conductor. In conclusion, terminating metal-clad cable with a cut-short grounding conductor into a box with concentric knockouts is prohibited by NEC 250.97. The cable can only be used in circuits up to 250 volts and must be properly bonded and grounded. Snap-in style connectors are not approved for use with this type of cable termination. Grounding and bonding are critical aspects of electrical safety, and improper installations can lead to dangerous situations, including electrical shock and fire hazards. Understanding the specific requirements of the National Electrical Code and adhering to manufacturers' instructions are essential for ensuring a safe and compliant electrical system. The grounding conductor plays a vital role in providing a low-impedance path for fault current to return to the source, allowing overcurrent protection devices such as circuit breakers or fuses to quickly trip and interrupt the circuit in the event of a fault. Without a proper grounding path, fault current may flow through unintended paths, such as equipment enclosures or building structures, creating a shock hazard for anyone who comes into contact with energized metal parts. Bonding refers to the process of connecting all metal parts of an electrical system together to create a common electrical potential. This helps to minimize voltage differences between different metal parts, reducing the risk of electric shock. Bonding is typically achieved by using bonding jumpers or bonding conductors to connect metal enclosures, raceways, and other metal components together. The use of concentric and eccentric knockouts in electrical boxes can present challenges for maintaining proper grounding and bonding. Concentric knockouts are designed to be removed in multiple steps, creating a series of rings that can be easily broken away to accommodate different sizes of conduit or cable connectors. However, the presence of these rings can create a gap between the connector and the box wall, which can compromise the grounding path. Eccentric knockouts are similar to concentric knockouts, but the rings are off-center, making it even more difficult to achieve a solid electrical connection. When using metal-clad cable with a cut-short grounding conductor, it is especially important to ensure that the grounding conductor is properly terminated to the electrical box. The cut-short grounding conductor is designed to be connected to the box using a suitable connector that provides a reliable electrical connection. The connector should be listed for use with metal-clad cable and should be installed in accordance with the manufacturer's instructions. It is also important to ensure that the grounding conductor is properly sized for the circuit it serves. The size of the grounding conductor is typically determined by the size of the ungrounded conductors in the circuit. The National Electrical Code provides specific requirements for grounding conductor sizing in Table 250.122. When terminating metal-clad cable in electrical boxes with concentric or eccentric knockouts, it may be necessary to use additional bonding means to ensure a proper grounding path. One common method is to use a bonding bushing to connect the cable connector to the box wall. A bonding bushing is a special type of connector that has a sharp edge designed to bite into the metal of the box wall, creating a secure electrical connection. Another option is to use a grounding lock nut, which is similar to a bonding bushing but is designed to be used with threaded conduit or connectors. The voltage limitation of 250 volts for metal-clad cable with a cut-short grounding conductor is based on safety considerations. Higher voltages can increase the risk of arcing across the gap between the connector and the box wall, which can create a fire hazard. Therefore, It is important to ensure that metal-clad cable with a cut-short grounding conductor is only used in circuits that operate at 250 volts or less. Snap-in style connectors are generally not approved for use with metal-clad cable with a cut-short grounding conductor because the snap-in action can damage the grounding conductor. These types of connectors are typically designed for use with non-metallic sheath cable, which does not have a separate grounding conductor. When using metal-clad cable, it is important to use connectors that are specifically designed for use with this type of cable. These connectors typically have a screw-type termination that provides a secure and reliable electrical connection. In addition to following the requirements of the National Electrical Code, it is also important to follow the manufacturer's instructions for the cable and connectors being used. The manufacturer's instructions provide specific information on how to properly install and terminate the cable and connectors, and following these instructions can help to ensure a safe and compliant installation. It is also important to ensure that all electrical work is performed by a qualified electrician. A qualified electrician has the knowledge and experience necessary to safely and properly install electrical wiring and equipment. They are also familiar with the requirements of the National Electrical Code and can ensure that all work is performed in accordance with these requirements. Improper electrical installations can be dangerous and can lead to serious injuries or even death. By following the requirements of the National Electrical Code, following the manufacturer's instructions, and using qualified electricians, it is possible to create a safe and reliable electrical system. Remember that electrical codes are constantly evolving to incorporate new technologies and address emerging safety concerns. It is essential to stay updated with the latest revisions of the NEC and other relevant standards to ensure compliance and maintain a safe electrical environment. Furthermore, consider the specific environmental conditions when selecting and installing electrical cables and connectors. Factors such as temperature, moisture, and exposure to chemicals can affect the performance and longevity of electrical components. Choose products that are rated for the intended environment and follow the manufacturer's recommendations for installation and maintenance. Regular inspections and maintenance of electrical systems are crucial for identifying and addressing potential problems before they escalate into safety hazards. Conduct periodic visual inspections of cables, connectors, and other components to check for signs of damage, corrosion, or loose connections. Use appropriate testing equipment to verify the integrity of grounding and bonding connections and to detect any insulation faults or leakage currents. Promptly address any identified issues to prevent electrical shocks, fires, or equipment failures. Consider the use of additional safety measures such as ground fault circuit interrupters or arc fault circuit interrupters to provide enhanced protection against electrical hazards. Ground fault circuit interrupters are designed to detect small imbalances in current flow and quickly de-energize the circuit to prevent electric shock. Arc fault circuit interrupters are designed to detect the presence of dangerous electrical arcs and de-energize the circuit to prevent fires. These devices can provide an extra layer of safety, especially in areas where there is a high risk of electrical hazards such as bathrooms, kitchens, and outdoor locations. When working with electrical systems, always follow safe work practices and use appropriate personal protective equipment. Wear insulated gloves, safety glasses, and other protective gear to minimize the risk of electrical shock or burns. De-energize circuits before working on them whenever possible, and use lockout-tagout procedures to prevent accidental re-energization. If you are not qualified to perform electrical work, do not attempt to do it yourself. Hire a qualified electrician to perform any electrical work that you are not comfortable with. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. By understanding the risks associated with electricity, following safe work practices, and using appropriate safety measures, we can create a safer environment for ourselves, our families, and our communities. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding and bonding, and equipment installation. It is essential for electricians, contractors, and other electrical professionals to be familiar with the requirements of the NEC and to follow them carefully when performing electrical work. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. In addition to the NEC, there are other relevant standards and regulations that may apply to electrical installations. These include the National Electrical Safety Code, which covers the safe installation of electrical power and communication lines, and the Occupational Safety and Health Administration regulations, which cover workplace safety. It is important to be aware of all applicable standards and regulations and to follow them carefully when performing electrical work. Electrical technology is constantly evolving, with new products and techniques being developed all the time. It is important to stay updated with the latest advancements in the field to ensure that you are using the safest and most efficient methods. Attend training courses, read industry publications, and participate in professional organizations to stay informed about the latest developments in electrical technology. Electrical safety is not just about complying with codes and regulations. It is also about using common sense and good judgment. If you are unsure about something, ask for help. It is always better to be safe than sorry when it comes to electricity. By following these guidelines, you can help to prevent electrical accidents and create a safer environment for yourself and others. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always treat electricity with respect and follow safe work practices.